So today we're going to start with something that looks a little different than what we just ended the last section with. It's actually an application that involves polynomials, and you've seen it before. We saw it a couple of lessons ago as well, but in a different form. So we're going to talk about it as the Pythagorean Theorem. So the Pythagorean Theorem is actually an application of the distance formula, because what it really finds is length of line segments between vertices of a right triangle. If A and B are legs of a right triangle and C is the hypotenuse, or the side opposite the 90-degree angle, then A squared plus B squared equals C squared. So here's my 90-degree angle, here's C, and then the A and the B can be wherever you'd like on the other two, or on the two legs. So no matter which two vertices I'm taking, let's say I take these two that I'm highlighting sort of in red. If I want to find the length between them, that's simply a distance, right? The shortest distance between 2 points is a straight line, right? You've heard that before. If I find the distance, I could use the distance formula to do that. All the Pythagorean theorem is an abbreviated or an application of the distance formula. And I can find any side if I know the other two. There's nothing special about like, oh, it says equals C squared, so I can only find C if I know A and B. No, I can find any of the three sides if I know the other two. So we're going to do a couple of examples of how we use the Pythagorean theorem when we're given pieces of information about a right triangle. Good to switch slides? Everybody all right? Okay. So here are a couple that we're going to take a look at. I didn't mark them out. I will right now, actually. So this is my right angle on this one. And this up here is my right angle on this one. Okay. On the left-hand side one, the first thing you need to be sure of and recognize is which is the hypotenuse. Is the hypotenuse the 4, the 40, or the x? It's the x. So when I set up my equation, I need to make sure that the equals the hypotenuse is the part that's alone, and the two legs are on the side with the summation. So I've got 4 squared plus 40 squared equals x squared. Okay, is everybody good with that so far? You have to make sure you're plugging them in, if you want to say it that way, in the right locations, or it's not going to work. Some of the problems that we're going to work with are going to end up with some bigger values of multiplication, so having your calculator handy is probably a good idea. And we're going to do some square rooting that's also going to be handy. Notice the directions here say to find the length, and that if we need to, we're actually going to be able to round on this problem. Okay? So your calculator is usually very handy when it comes to rounding things. All right, so what is 4 squared? 16. And what is 40 squared? 1,600. Excellent. All right, so then we're going to be able to add those together. So what is 16 plus 1,600? 16. And then what do you suppose we would do to find x? We would take a square root. I do hope you have a calculator that has a square root button. You're going to need it for this particular lesson because there's going to be a couple of places where you're going to need to round something. So what does your calculator say? The square root of, I'm sorry, there's a typo on my screen, but it's okay, we'll just go with it. What is the square root of 1616? With an approximation rounded to 2 decimal places, right? Hundredths place means 2 decimal places. 40 point what? So is it like 20? Is that what's next? Yeah. Okay, so we'll write the 0 just to make sure that we're clear that we looked at it and we really know it's a 0 next. All right? 40.20. The problem originally didn't have any decimals because I rewrote a side wrong when I typed it in my computer, apparently, for the slide. That's all right. It's all good. All right, let's try another one. On this one, which side is the hypotenuse? The 12. So the 12 is the part that will be alone, equals 12 squared. So the x squared and the 6 squared will be added. All right, so what is 6 squared? 36. And 12 squared? 144, good. So what will I do next? Yep, subtract the 36, which will give me what? What will x squared equal? 108. And then what? Square root, you got it. So what is the square root of 108? 10.39. That's what I have written down too. Did everybody get that to show up in your calculator that way? Is that right? Okay. Now we're using something when we're doing these problems sort of by accident. We're using something called the square root principle. But we're noticing that when we took a square root here, we're about to show you something different, we don't have to worry about is it positive or is it negative. For example, let me just give you a simple value. Let's say you had x squared equals 4. And you wanted to take the square root of both sides, and you would have told me that x is equal to 2. Now, if we're talking about lengths of things, you'd be right. It would have to be 2. But if we're talking about the fact that there's actually 2 answers, what would the other answer be? What other number times itself is 4? What is it? What other number times itself is 4? Negative 2. Thank you, Lauren. Negative 2. Right? You guys with me? Negative 2 times negative 2 is also 4, isn't it? Now, when we're looking at distances and lengths of sides of triangles, it doesn't matter because distances can't be negative. So it doesn't make any difference. But when we're looking at other types of applications and other types of problems, that is a valid solution. So what we're using is called the square root principle. So if we have a problem where it says x squared equals a number, okay, that number here I've used is k. If the k value is negative, there's no real number solution. So that would look something like if you had x squared equals negative 9. There are no 2 real numbers. I shouldn't say it that way. There's no one real number that when multiplied by itself is negative 9. It'd have to be 2 separate numbers. Right? Because positive times a positive is positive, a negative times a negative is a positive. I can't get a negative 9. It's not possible. But if I have a number that's bigger than 0, for example, if I had x squared equals positive 9, then there are actually 2 solutions because there is a positive 3 solution and a negative 3 as a solution. Because not all numbers represent distances. My previous problem did. Lengths and distances are positive values, but not all numbers are. And it is, in fact, true that negative 3 times negative 3 is 9, right? it is definitely a solution to x squared equals 9. So some of your answers are going to be no solution answers. And some of your answers are going to have 2 solutions. So let's take a look at a few examples. Does everybody have everything on this one written down? Yeah? Okay. So we're going to start with x squared equals 98. So let's start by identifying, does this have 0 solutions or does it have 2 solutions?
2 solutions.
2 solutions. Why, Karen?
Because it's positive.
You got it, because the 98 is positive. This will have 2 solutions. Okay, so I'm just going to write that down so that we know that we've, sort of thought about it. There's 2 solutions here. So how do I find them? I take a square root, you bet. And as we're working on these problems, if it doesn't say to round, we're not going to round. So the Pythagorean Theorem problems said we were rounding. This one doesn't. So square root of 98, if you put it in your calculator, gives you something funky. What's it say? 9.89, and a bunch of decimals that never end, right? Okay. So that tells you it's not a whole number value, which you probably suspected as much because we've talked about square roots in class a little bit, right? Those perfect square roots from back on the first exam. So we need to factor it instead. So I heard, Josh, what were you saying back there?
It would be 9.89, but when you round it up, it would be...
Okay, I'm sorry. Pause for a second. We're not rounding.
Okay, so we don't have to do that.
There, so that's... Okay, slow down for me, buddy, slow down. Okay, do you see how the directions here just say solve?
Yeah.
But when we were looking at it over here, it told us to round in the directions.
Yeah.
We're not rounding on this one, okay? If it says round, though, you're exactly right. You would do that. Okay, so if it doesn't say to round, we're going to keep our answers exact, which means to work out the solutions like we did when we were simplifying radicals a couple sections ago, right at the very end of the last unit. What will 98 divide by? 2 is a lovely number, and it gives me 2 times what?
49.
49, which is also actually very friendly, because 49 is probably a factor, or a term that you know how to factor, right? Yeah, 7 times 7. So when I take a look at this, the first thing to remember is that you need to put a plus or minus on here, right? 2 solutions. And then you have 2 times 7 times 7. And there's a group of 2 7s. So what happens to the 7s? They come out. And they come out, but not in front of the plus or minus, okay? They're still plus or minus of all that stuff. So it's still 7 in the front, and then square root 2. So this is what we would get for our solution. Plus or minus 7 square root 2. If you really want to wait until the very end to put the plus or minus on, just so it doesn't distract you while you're simplifying radicals, I'm okay with that. You can do that. But please remember it, because there are 2 solutions that need to be present. Okay, what about number 4? How many solutions are there? There's only 2 options. There's either 2 solutions or no solution. It's no solution. Try something for me. Grab your calculator. I would like for you to try square root -4 just for fun. Your calculator's going to do one of 2 things. What did yours do, Connor?
Error.
Did it say error? Most of them will say error. It depends on the modes that you're in your calculator. Most of them will say error, or it might even say dim mismatch. Sometimes you'll see that error code that will show up, dimension mismatch, or domain error. Sometimes they'll have the word domain in it. Did anybody's actually give you a solution? No? Depending on the mode, it sometimes will give you solutions that have imaginary numbers in it. But we're not working in the imaginary numbers, we're working in the real numbers only, okay? So there are no numbers that you can multiply together by themselves and get a -4, right? 2 times 2 is, what are we on? 36, not 4. 36. 6 times 6 is 36, but not -36, right? Negative 6 times negative 6 is 36, not negative 36. So this actually has no solution. And you're going to have a few on your homework that are going to be no solution. And you know what? That's awesome. You know why? There's no work to do. It's the simplest problem, right?
So why is there no solution?
Because there's only two numbers that give you 36. And neither one of them give you a negative 36. These are both positive 36.
The two numbers need to be the same number.
That's what by definition a square root is it's the same number times itself. So yeah. Okay? So if you've got it equal to negative, in this case 36, there is no solution for that. Okay, we're going to expand this problem a little bit. Are you ready? Looks really different. It's really not. It's very, very similar. What I don't want is I don't want you to square out the part that's in the square. That's not the goal here. The goal is to take what we've been doing and be able to use that for this problem. So take a look at what I'm going to do. We're going to start by adding 32 to the right hand and left hand side. Now, if you take a look at this and you were to sort of cover up the w minus 8 and it just said something squared equals 32. Won't that look a lot like that last problem that we did, number 3? It does, right? Okay, so that's what we're going to do. We're going to do that same process. This says something squared equals 32. Well, the way I get rid of a square is I square root. So we're going to square root both sides. On the left-hand side, the square and the square root are going to cancel one another out, right? They're inverse operations. So I end up with w minus 8 on the left-hand side. Square root 32 is not going to actually give you a whole number value, right? If you try it, it's going to give you some decimal craziness going on there. So we're going to have to factor it. How will 32 factor? It'll divide by 2 to give me 16. 4 and 4, sure. And each of my 4s gives me 2. So how many 2s do I have? 5 of them, you bet. So how many pairs are there? There are 2 pairs underneath. Pair number 1, pair number 2. So now I still have w minus 8. I have a plus or a minus here, right? Because I put the square root into the situation. This pair of 2's is going to come out as 2. This pair of 2's is going to come out as 2. So that's a 4. Square root 2. It's ugly, I know. But it's correct. But my goal is to solve for w. So what's the last thing I would need to do? Add 8 to the, well, to both sides, but to move it to the other side, I would add 8. Now, please don't misunderstand. I cannot combine this 8 with the 4 square root of 2. They're not like terms, right? Just like when we did radicals back in the last unit. Those are not alike. So what do? Well, I actually put it in front of the plus or minus. You can put it behind if you want to. It doesn't hurt anything. It's easier, I think, to put it in front because it never looks like it accidentally gets sort of lumped underneath the radical by accident. That's why I put it in front. Okay, I have one more of these. Same type of problem. What would I do first? Yeah, I'd add the 25. My goal is eventually to have the ability to take a square root. So I have w plus 9 squared equals 25. Then what? Yeah, I'm going to square root. But this is a nice one to square root. What do I get when I square root 25? Close. Plus or minus 5? right? 5 and negative 5. Now this is a little different because the last step that I did on the last problem was that I added 8 to both sides, right? And I'm going to add the 9 to both sides, subtract the 9 from both sides as well. But the 9 that I move will be able to combine with the 5. Those terms are alike. So once I have the ability to combine something, it might actually be easier to write out the fact that I have two things that are actually, going on here. I have w plus 9 equals 5, and I have w plus 9 equals negative 5, because I'm actually going to be able to combine them. And I'm not going to get plus or minus the same value when I do it. I'm going to get two distinctly different looking values. So when I subtract the 9 on the first one, what's 5 minus 9? Negative 4. And when I subtract the 9 on the second one, what am I going to get? Yeah, negative 14. Negative 14. I have one more problem left today. Slightly switching gears again is another application of polynomials. Imagine you've seen it before. It's called the quadratic formula. So if ax squared plus bx plus c equals 0, a, b, and c are real numbers, and a is not 0. That won't work if a is 0, because then it's not a quadratic. Then x equals negative b plus or minus the radical of b squared minus 4ac all over 2a. Has anybody ever heard a song that goes with that before? Some of you are smiling, so I know you've heard it. Yeah, Sarah's like, I sort of have. So I'm going to sing you a song. I don't sing, just so you know. That would be my husband. He's the one who leads worship. But I'm going to sing you a song to the tune of Pop Goes the Weasel. I don't know if you've heard Pop Goes the Weasel before. It's kind of an old tune, but it goes something like this. X equals negative b plus or minus radical b squared minus 4ac all over 2a. And this is now on YouTube. Isn't that exciting? Super exciting right there. Okay, so whatever it takes for you to remember this formula, this is a super friendly formula because when things don't factor nicely, this will still allow us to solve problems. And that's really good. So jot that down, and then we're going to do one example with it. Okay, I'm going to rewrite on the next slide anyway, so. All right, so we need to identify the A, the B, the C. So A in ours is 9. B is 4, and we've got a problem. What's my problem with the 1? Does anybody know? It's on the other side of the equal sign. So before I get too far into this, let me actually take a step back and move it. We need the 1 to be on the left-hand side instead of on the right-hand side. So I have 9x squared plus 4x, and it should be minus 1, right? So this value is actually C. All right, so I have negative b, so that would be negative 4, plus or minus square root of b squared, so that's 4 squared, minus 4 times a is 9 and c is negative 1. Please, please keep your signs attached to their numbers. Divided by 2a, so that's 2 times 9. Negative 4. 4 squared is 16 plus 4 times 9 times 1 is 36. And it's a plus because there's 2 minuses, right? There's a reason we talked about all that integer stuff, back on day 2 of class or whatever it was. And this is dividing by 18. All right, what's 16 plus 36? 50? 52? What'd you guys say? 52. Yeah, that's what I have. Good. divided by 18. 52 can be broken down. It's 2 times, well, it's 4 times 13. And then 4 is 2 times 2. And there is a pair. So that pair of 2's will come out as a single 2. Still have a square root of 13, and it's over 18. Those 3 numbers that I highlighted in yellow are the ones we compare. If they all have something that can reduce them, we reduce them. If they don't, then there's nothing else to be done. Can I reduce those 3 numbers? Yes. What will they all divide by? 2. So I will divide each one of them by 2. So I have negative 2 plus or minus. You can write a 1 if you want, or you can simply write the square root 13. Or you would write 1 square root 13 to clarify. And then over 9. Okay, I have 2 sets of homework to pass out to you. All right? Because we have now finished both of these sets of material. There is one, not correction, but I guess correction. Now, there's one thing I want you to change about a direction set. It's not in the one I'm handing out right now. Neither of these homework sets are extremely long. They're shorter than the longest one I've given you combined, actually. Some of them work through very quickly, of course, and others are a little longer. Please take the homework 15, one I'm passing out right now, and turn to the very back. Oh, I think I gave you one extra. Problems 14, 15, 16. Do you see 14, 15, 16? It says round to the nearest hundredth. Mark that out. I do not want you rounding those last 3 quadratic equation problems. 14, 15, 16. Mark out rounding. 14, 15, 16 on homework 15. Yes, I'm sorry. I understand now what you just asked. Homework 15, 14, 15, 16. Mark that out. Don't mark out the problem. We're going to do the problem. Mark out the rounding part. We're going to do the problem. We're just not going to do the rounding part of it. Okay? Sorry. I'm glad I just saw you do that by accident. Yeah. Okay. Everybody catch that? You're doing the problems. You're not doing the rounding. If you were, or if you are, Macy, L'Oreal, Karen, Chloe,